All right, so my name is Philippe Bergeon. I am a product manager at Nokia, and I'm here to discuss network security in the context of DDoS. And in particular, I'm going to try to answer the question on this slide, which really is what can be done in 2019 to solve distributed denial of service attacks and large-scale volumetric attacks in general. And to answer those questions, I'm first going to walk you through the different solutions that have been deployed by network operators over the past 15 years up until now, and also present you some new solutions available today from Nokia to address this particular concern. So if you're looking at the state of internet today, and with this ever-growing number of devices connected to our networks, those are really a great opportunity for malicious actors to launch powerful distributed denial of service attacks. The way it works is that those malicious actors take advantage of compromised devices. Those can be server applications, they can be home gateway routers, and especially in the past couple of years, IoT devices have been a prime target. So those attackers take advantage of vulnerabilities in those devices. So it can be, for a server application, an administrator that is not using the proper security configuration for that particular server, but that's not very common. It can happen. What's really a prime target is IoT devices, especially in the past couple of years with the rise of those number of devices. And unfortunately, those have been prime targets because this particular market segment really has not focused on security in general. So those devices are unsecure by default or have a very low security posture. So if you're looking at the largest botnet today, they can comprise tens of thousands of devices to hundreds of thousands of devices. So really with this larger number of devices that can be used by attackers, those are really fueling much more powerful distributed denial of service attacks. So when in the past, distributed denial of service attacks used to be in the gigabit range 10 years ago, launched by a couple servers to an attack target, nowadays, distributed denial of service attack can reach terabit level attacks. So if you've seen in the news in the past couple months, it was no later than last year, there's been the two largest distributed denial of service attacks to date. So one was on GitHub, and the other one was on a North American provider. So those attacks were to the range of 1.3 terabit per second to 1.7 terabit per second. So really, we're on a very different type of scale of attack. And when you see this type of attack and the frequency of those attacks, you kind of have to ask yourself the question, so how can you protect your network from such an attack? Is your network ready to sustain such an attack? Or are you going to be the new network operator that is going to be in the news, such as in this slide, as being a victim of such a large distributed attack? So in order to walk you through what has been deployed and what could be deployed by network operator, first I'm going to give you a couple of slides on typical solution that have been deployed. So the most common solution that has been deployed is a centralized scrubbing center. So in this particular case, this is the case where the attack is typically coming in northbound, so from your peering edge and attacking a particular target within your network. So this would be typically a data center application or a business customer. And so this attack is detected at the peering edge. So using NetFlow type of telemetry information, the attack is identified and the traffic is being redirected to a centralized scrubbing center. From there, the traffic is cleaned and sent out to its final destination. So this type of solution works fine up to the final amount of traffic that centralized scrubbing center can process. And it's also typically targeted to protect a certain set of business customers or typically your data center application. But it doesn't protect your network infrastructure as a whole. It doesn't protect your subscriber either. So what can be done to protect all those assets within the company? So this type of solution is really addressing a specific set of the market segment and is also limited to the maximum capacity of that particular scrubbing center. And when this scrubbing center is typically out of capacity, what can be deployed is a very basic mitigation rule at the peering edge to completely drop all the traffic going to a particular customer. So obviously, from a user experience and from a customer experience, this is obviously not the greatest experience because at this point, we have completed the DDoS. Another type of mitigation that can be deployed is simply installing an appliance in front of a customer. So instead of being offline, like the offline scrubbing center, the appliance can be inline just in front of the customer site. So this can be deployed in front of many customers. Obviously, there is a cost for this type of technology, and there is also a limitation, which is this particular customer is only able to mitigate the attack to the scale of this particular appliance, and also to the scale of the link and the bandwidth to that particular site. If the attack was to be larger than the site, then the attack is completed at this point, again, in this particular type of design. So what we are seeing is that, what we've seen from our customers is that really the attack surface and the attack parameter is really changing. So like I mentioned earlier on, we have compromised devices not just coming from the internet, but those compromised devices can also be located from within your own network. How can you mitigate those? You cannot mitigate those using the centralized command center or within the inline appliance. So in order to mitigate this type of attack, you really need to rethink the security from within your own network. How can you protect your network from a compromised subscriber or a compromised data center application that would launch an attack either to your own network or to the outside world? And this is where you need to really have a different type of solution where the network would be basically mitigating the attack on behalf of the network operator. And if you're looking at subscriber today, so the subscriber bandwidth is much higher than it used to be. And we've also already had a couple of examples of networks that have been impacted by a large number of subscribers launching an attack towards the network operator infrastructure itself. So this can typically be done by devices from within the subscriber network that are used as part of a botnet, or also more typically the home gateway itself. So if the home gateway itself is vulnerable, then it can be used as part of a DDoS. So what we're looking at is, and what I'm going to present you for the rest of the slide, is really how can you make the network part of the solution? So it's really a future mode of operation where instead of using the current mode of operation where the traffic is being redirected to a centralized scrubbing center, like you can see in this slide right now, where the traffic is northbound from a peering edge detected using NetFlow, redirected to a scrubbing center, cleaned there, and sent to its final destination. What we're looking at is a future mode of operation where with the capability to do payload inspection in the router itself at the speed of the line card. Now, instead of mitigating the attack centrally located within your own network, we can mitigate the attack at the edge of the network. So with this type of technology now, you can mitigate the attack at the IP peering edge, at the subscriber edge, or at the data center gateway edge. And this is really a shift in really mode of operation and the capacity of for the network operator to mitigate an attack. Now you can mitigate attack at the speed of the network. So you can mitigate terabit level attacks. You can mitigate attacks coming from inbound, outbound. So those type of capability are really critical for the scale of DDoS attacks that we can face today, and also really critical for protecting the entire networks. So when today you can only protect a single customer or a set of customers, with this type of technology, now you can protect the entirety of your network infrastructure. If you have a DDoS attack that is towards a set of subnet within your infrastructure, which has happened to a number of our customers, this type of attack can hardly be sent to a centralized scrubbing center. But by deploying this type of technology at the IP edge of the network, now we can leverage the router itself in order to mitigate the volumetric part of the attack. You would still have scrubbing center or inline appliances within your network, and this would be for mitigating application layer attack, but the volumetric part of the attack is now mitigated within the router itself. And this is using two key components. It's this payload inspection capability in the router and a large-scale ACL filtering at the rate of the line cards. So what exactly do we mean by payload capability and payload inspection? So if you're looking at traditional router, so a traditional router has a visibility into the IP header, the TCP, and the UDP header. And so typically a traditional router can write ACL based on IP address or port number. So now what you can do with our latest network silicon, which is the FP4, so you can write ACL not just based on IP header and TCP header, you can write ACL based on IP header, TCP header, and the payload of the, within the data. So now basically, instead of dropping traffic based on a port number, so for instance, NTP is port 123, and instead of trying to drop or rate limit the entirety of NTP for an NTP reflection attack, what you can do is match a particular payload within the data and only rate limit this particular traffic. So essentially, dropping the traffic based on the signature. And this signature would be the signature marking for that particular distributed denial of service attack. So this is really a shift in capability in the router. And with the rise of IoT devices and those terabit level attacks, we believe that this type of technology embedded in the router is really key to mitigate large-scale attacks today. So how do we do it? So we have this capability in the router. So we have this payload inspection, this large-scale URL filtering capability in the router. But we also need an analytic platform. So obviously, this is something that we have also within Nokia. This is our Nokia Deep Field Analytic Platform, and this is what we use to identify the DDoS and to program the filtering rules into the router. But really what we have is a closed loop, a closed mitigation loop. So we have this analytic platform which is able to ingest telemetry data from the network element. So this telemetry data is related to flow information, related to payload information, and based on this information can correlate and identify invariance in traffic. And this analytic platform is also able to identify what are the different IP address part of the attack. So are those IP addresses part of a known botnet? Are those IP addresses part of a cloud infrastructure? Or are those IP addresses part of an IPTV network? So those are all metrics that are available in the analytic platform in order to make the decision to drop or rate limit a particular traffic. So for instance, if you have an invariance in traffic, and if we see that the traffic is all coming from Netflix, because there is a shift in Netflix cloud infrastructure, then we obviously don't want to drop Netflix traffic. So all this is part of this analytic platform that allows us to identify the DDoS based on invariance in traffic and based on our cloud genome intelligence. And using those metrics, program the filtering rules down into the router. And then what you really need is you really need a closed mitigation loop, because as a network operator, when you deploy mitigation, what you really want to know is after you've deployed the mitigation, you want to understand if this mitigation is actually working or not. So you need feedback telemetry in order to understand if the filtering rules that you've deployed are dropping traffic or not. So this is our closed telemetry feedback loop, where from the analytic platform, you can see that you have your mitigation ongoing, and you can see that the traffic is being dropped to the level that you expect. So if you have a 10 gig attack or a 100 gig attack or a terabit level attack, then you see that the attack is ongoing, and you see the number of packets dropped within the router that would match the size of the attack. So I'm going to walk you through a couple of practical volumetric DDoS that we mitigate with this solution. But before that, it may be a little bit useful to walk you through volumetric attack in general and what they represent. So if you're looking at volumetric attack, there's really two main categories. So the first category that is shown in this slide is a direct volumetric attack. So in this particular case, we have an attacker which is controlling a botnet and launching a coordinated attack towards a given target. Those attacks can be extremely powerful. Like I mentioned earlier, those botnets can be tens of thousands to hundreds of thousands of devices large, right? The second type of attack is an amplification reflection attack. So in an amplification reflection attack, we have an attacker which is taking advantage of open resolvers on the internet, such as an open NTP server or an open DNS server. And in this case, the attacker is sending forged traffic with a spoofed source IP. And this is basically driving the server to respond to the attack target, which is the forged source IP. So in this particular case, those are also very powerful attacks because the traffic is amplified in this case. So the response is larger than the request. The amplification ratio can be in the hundreds or in the thousand in some cases. So in this case, they can form extremely powerful attack with a smaller set of clients that are compromised. So really from the attacker, from the network under attack point of view, the first line of defense has really typically been the IP peering edge, but for doing many, mostly simplified ACL, so doing anti-spoofing or basic ACL filtering. But now what you can do using the solution I've mentioned is using those new FP4 capabilities, so using this large-scale ACL filtering and this payload filtering capability in the router. Now the network operator can mitigate the attack straight at the peering edge. So in practice, there's a number of volumetric attacks that exist today. So amplification attack is one of the most common, and NTP reflection attack is one of the most common ones. So in this particular case, you have an attacker which is sending a forged request to an open NTP server, and the response is amplified to the attack target. So in this particular case, what you have in this particular slide is a capture of an NTP amplified packet. And in this particular case, we can leverage the FP4 capability and the capability in the router to write ACL based on 5-tuple information and the payload within the data itself in order to mitigate this particular attack. So what you can see highlighted in red in this particular slide is the signature of the attack. So in an NTP reflection attack, those are called NTP monlist attack. We can match this particular type of attack by matching the exact monlist request within the packet payload itself. So after the UDP header, within the NTP payload, we can match this particular traffic. So this is the signature you can see here, this 1700032A. This is something that we can write as a normal ACL, as a standard ACL on the router. So instead of dropping the entirety of all NTP traffic, we can match and be surgical in the mitigation. And so now, instead of dropping the entirety of NTP traffic, we can only drop the NTP reflection attack and leave the rest of the traffic untouched at the speed of the router. So this is really a shift compared to what you could do previously. Another type of attack could be a TCP SYN flood attack. So in the case of a TCP SYN flood attack, you have a large botnet, and this botnet is used in a coordinated attack towards a single target. So again, for those type of attacks, we can use the FP4 capability in order to match a particular signature within the traffic in order to drop only the attack traffic from the good traffic. So this is a real case scenario where the particular attack was launched by a botnet, and all of the TCP SYN packets that were sent in an attempt to overload the attack target had a common signature. The common signature was found from within the TCP SYN option fields. So it's a combination of field within the TCP option. In this particular case, the no operation, the window scale, length, and shift count. And this can be used again as a a match criteria from within an ACL in the router in order to drop this traffic in line at the peering edge or the subscriber edge where the attack is coming from. So you can write this ACL in the router and drop this attack traffic on the floor and avoid dropping all of the TCP SYN from within your entire network. So another type of attack is a DNS reflection attack. So in this particular case, I am showing a DNS type any reflection attack. So in this particular attack, similarly to the NTP attack, you have an attacker sending a forged request to an open DNS resolver, and the DNS response is being sent back to the attack target. And in this particular case, well, the response is larger than the request. It's an amplification attack. But there is a specific field that we can match within the data payload. And this particular field is the type any for a DNS type any reflection attack. And we can match this particular field using a pattern match capability, write this filter as a standard ACL, and drop this traffic within the router again. So if you're looking at the entire mitigation workflow, there's really 4 steps in the mitigation workflow. First, there is an attack that's ongoing to the network. This attack is being detected. So this is the telemetry information sent to an analytic platform. Once the attack is detected, then the mitigation is being programmed in the router. So we are looking at invariance in traffic, like I mentioned earlier on, and then programming the proper filtering rules down onto the router. But if you're looking at the complete mitigation workflow and the detail of which interface we are using, so we are only using standardized interface. So when the attack is coming in the router, the first thing that we have is we have netflow, cflow type of information sent to the analytic platform. So this is used to identify invariance in traffic based on 5-tuple information. But as you know, netflow doesn't include the payload information. So how do we get the payload information inside the analytic platform, which is offline? So the way it works is that the analytic platform is sending rules to the router in order to selectively mirror a specific part of the DDoS over a GRE tunnel to the analytic platform. So this is what we call intelligent sampling. So only specific part of the attack traffic is being selected in the router and sent to the analytic platform. So this is how now the analytic platform has both the 5-tuple information and the payload information in order to program the filtering rules down into the router. So this is a third step in the mitigation. So in this step, we're using either BGP flow spec or netconf in order to program the network element. And the last step in the mitigation workflow is our telemetry feedback loop, where we're sending telemetry information back to the analytic platform in order to identify how efficient was the mitigation. So this is what I mentioned earlier. From the analytic platform, you can see the number of packets being dropped for a given attack. So what I've mentioned up until now is where all those known DDoS attacks that we can mitigate and within the router, leveraging our payload capability in the FP4 platform. But there's another type of mitigation that can be done in the router. So instead of doing blacklisting, which is like identifying the bad flows and dropping the bad flows, what we can use the router for is for whitelisting traffic. And this can be particularly useful for specific type of use cases. So this one is a gaming application example, where in this particular case, instead of dropping all of the bad traffics, if you're in a situation where you control both the client application and the server application, such as in a gaming operator type of network, then you can define a known good pattern within the data payload. And by only allowing this known good pattern, then by default, the router will drop all of the bad traffic trying to go to that particular server application. So this is actually something that's, this type of deployment have already been deployed by gaming operators. This is something I just learned this week. So using this type of deployment and solution, you don't need to chase the byte flow. You can only, the router would automatically drop all of the bad flows straight in the router because they don't match this particular pattern. And so this is ending the presentation today. So really, I hope that you are having a different perspective now on how to mitigate DDoS. You've seen the different technologies that have been deployed over the past 10, 15 years using centralized command center, and what can be done nowadays in the router in order to mitigate the attack traffic straight in the router, in the line card, at the speed of the router. So this is a solution that can be deployed today, and that's available from Nokia. And if you have any other question, don't hesitate to ask. 0.
So, thank you, Philippe. Any questions? Are there? Do we have a mic? Well, she's have like 5 seconds. So one of the benefits with doing a presentation on the Friday morning is actually that you have 30 minutes instead of a normal 20 during the rest of the week. So we have a little bit of time.
Okay, good. I have 2 questions. Do you use BGP blocking for the community blocking?
BGP, so we can use a BGP flow spec for programming the filtering rules and netconf as well.
No, I mean using your peering edge.
Yeah.
So you set the community 666 and push that to your remote peering community, and they will block the traffic for you.
So, but this would be So this would be dropping traffic nodes based on the payload information. So this is
yeah, you can do that, and you can ask your peer to do it, and that will remove the load. You can ask your peerings like Fran6 and DKIX to use the blocking community, and you just add a community to the payload, to the route, and that will not be sent to you anymore.
So you cannot. So unless you have a router that allows you to drop the traffic based on a specific payload, then you wouldn't be able to do that.
Well, you identified the payload that is wrong. You identified the sources of the IPs, right?
No, also, so the entirety of the game is actually to not drop the traffic based on just IP information, but just drop the traffic based on payload.
Yeah,
right?
But you could use that also. And the second part is can you handle 100 gigs of dropped traffic?
This seems like a debate. Okay. So take it outside in the corridor and take it where it belongs. We have to stop here and continue with the next presentation. Thank you, Philippe.
Thank you.